Okay, 4.7, piecewise functions. All right, what are piecewise functions? Well, it simply means you're going to take a graph and you're going to take a piece of it. All right, now how exactly does this work? All right, let's just focus on this right here. This you've seen before, okay? You've seen that before, x minus 2. If you look at the grid over here, here's the line x minus 2. All right, there's the line. All right, and then here we have this. We have this other line. All right, so they're graphing multiple pieces to different functions or equations on the grid. So here we have the line 2x plus 1. Okay? All right, now what does this information mean here? That's where students get confused. Okay, x is less than or equal to 0. That means when I'm looking at the red line, I don't want the whole line. I only want the pieces of the line where the x values are less than or equal to 0. Well, that starts here. Here's 0 for the x values. And I use a solid dot because it includes 0. And all the points going to the left here have x values that are less than 0. All right, so that's all you want from the graph. The rest of the red, you could just erase it, delete it. All right, for the blue graph, all right, I want only the points from the line that are greater than 0 for x. So here's 0 for x, and I'm using an open circle because it doesn't say equal to 0. It says greater than 0. So all values greater than 0 would be to the right. So it's all the points on the line to the right. All right. So what you see in the green now is the piecewise function. Okay. So what you have in the blue and the red shouldn't even be there. And I'll actually delete it right now. So you could see at the very end what your graph is supposed to look like. All right, just get rid of all of it. All right, now it's all cleaned, and that's why you're left with those pieces that you see there. All right, for example 1, it says evaluate the function f above when x equals 0 and x equals 4. Okay, x equals 0. That satisfies, let me erase a little bit again. All right, that satisfies this condition here. All right, x is less than or equal to 0. So you're going to be looking at this line here. So at x equals 0, let's go down to the line x minus 2. All right, what is this point here? What is the y value? All right. So for part A, it says evaluate the function. So when x equals 0, you'll end up with, what's the y value here? -2. All right, so you'll end up with y equals -2. All right, for part B, use a different color. I'll use green here. All right, then it says x equals 4. X equals 4 satisfies this condition. X is greater than 0. All right, so if x is greater than 0, that means x equals 4 satisfies the restriction based on this equation, x plus 1. So we go over to x equals 4. It's right here. And I'm going to go up. All right, but it's off the grid. So we can't use the grid to solve this problem, but that's okay. I already know what the equation is. So just plug x in here. I mean, you didn't have to use the grid. So f of x, in this case, x is what? 4. All right, so I'm plugging in 4 for x. And I get 8 plus 1, and that equals 9. All right, so for part B, I get y equals 9. All right, that's all there is to that. Let's go on to example 2. All right, for example 2, we're graphing this piecewise function. Okay, how exactly is this going to work now? All right, let's first focus on this here. All right, what's my slope? My slope is -1. All right, but then we're going to write over 1 because we write it as a fraction when we're graphing. And my y-intercept is negative 4. Okay, so negative 4, that's my starting point. Then I apply my slope, down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Okay? Okay. So there's my line. Before I apply the restriction to it, the domain restriction. Okay? And let's see here. Oh, and it says and range. Okay, we'll get to that in a moment. All right, so here's my restriction here. I only want the parts to the line where the x values are less than 0. All right, less than 0. So that would be, that would be from this point to the left. All right, so that's all I want from the line. So let's erase the rest. All right, and that's gone now. All right. And it actually says just less than 0, so I shouldn't make a solid dot there. I should make an open dot because it doesn't include the value. All right, let's go on to the next one. Here I'm working with this graph. What's the slope? The slope is 1 over 1. Now I'm not adding or subtracting the number there, so it must be 0 for my y-intercept. So let's start off at 0 for the y-intercept, and then I go up 1, right 1, up 1, right 1, up 1, right 1. Down 1, back 1, down 1, back 1. Okay, and let's graph that. Then it says the restriction is greater than or equal to 0 for the x values. So here's 0, and it says greater than, so I'm going to the right. All right. Now erase that there. And now I have my piecewise function. Okay, so now describing the domain and the range. Domain are all the x values that are covered in this piecewise function. Now, all the x values, here are my x values. I have x values at 0 and less than 0, and it keeps going left. And here I have 0 again, but it keeps going right. So these are all the x values. So now these two graphs, the red and the blue, they'll cover all x values. So you could say all row numbers. Okay, but for the range, okay, domain is x values. Range is the y values that are contained in the function or the piecewise function. So if you look at these graphs here, so it starts down here at -4 for y. And now these two graphs, they just keep going up, 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 both of them, right? So they're covering all the y values that are greater than -4. So these two graphs, none of them contain y values that are less than -4, right? So the range describes the y values that are covered by the functions. So it's going to be all y values greater than -4. Okay. And one more example. Write a piecewise function for the graph. Okay, so this time we're going backwards now. All right, see what we have here. All right, well, here I have this one line. All right, and I could continue to go down like this. All right, what's happening here? All right, I know my b value for that graph is what? It's going to be -1. All right, what's the slope of it? Let's see, let's go to another point. I go up 2, and I go right 1. So it's 2 over 1. So here's one equation, y equals 2x minus 1. Okay? And now let's figure out what the restriction is for this. Let's see, what does the graph cover for the x values? Well, it starts here, and then it goes to the right. Okay, so it starts at 0, and it includes this point. All right, so it's going to be all x values greater than or equal to 0. All right, because we don't see any of this over here, right? All right, let's use another color now. Then I have this line. Okay, once again, y equals mx plus b. What's my b? All right, well, I'm going to go up 3. So I have y is equal to something x plus 3. What's the slope in this case? Well, let's see. How do I go from this point down to another point? Here's another point. So I'm going to go down 1, and I'm going to go left 1. So -1 over -1. All right, because you're going down 1, back 1. Simplifying that, we just get 1, or just x plus 3. All right, now what's the domain restriction for this graph? All right, so it starts here, and it continues to go to the left. What's the x value here? All right, 0, and then it goes to the left. So it's all x values less than 0. And you don't say equal to because it's an open dot. All right, so here's the information I have now. All right, now let's write this in function notation. Oops. All right, so we have f of x is equal to, you're going to use this bracket here. All right, now you don't have to use the y, all right, because the f of x represents your y. All right, now we're going to use 2x minus 1. On the bottom, we're going to have x plus 3. And on the top, we're going to say if, what's the restriction? X is greater than or equal to 0. And for the bottom line, we have x plus 3 if x is less than 0. Okay, so that's how you write out the function. It seems like there's a lot going on, but once you understand the basic concepts, it becomes to be very simple. If you have any questions, please let me know. Begin the assignment at the bottom of the webpage.